Unit 7, Lesson 5, Graphing Exponential Functions. So in this unit so far, we've learned how to do algebra work with exponents. So we've learned about exponent rules, how to simplify when you have a variable in an exponent, how to deal with rational exponents, okay? So the next lesson, the one we're about to do, we're going to look at what the graph of an exponential function looks like, okay? We know that a quadratic looks like a parabola. We know that a linear relation looks like a straight line. We learned that the sine function and the cosine function have their own unique properties, okay? We're now going to investigate what the graph of an exponential function looks like. So the first thing that you guys need to do for me is fill out the y values from each of these four tables, okay? So what you're going to do is one by one, you're going to plug in the x value and then solve for y. So for this very first one, okay, what's the y value that's associated with -2? Well, you plug in -2 in for x, and then you'd solve it. Okay, so that would be 1 over 2 squared, because we know that negative exponents are the same as their reciprocal with a positive exponent. So then the y value here would be 1/4. Okay, so go ahead and do that for each of these four tables. So please pause the video and do that, and then unpause when you're done and check your answers with mine. Okay, so hopefully those are the y values that you were able to come up with. The next thing I would like you to do is now graph each of these functions, okay? And make sure you are able to differentiate between each of the four graphs. So either label your graphs or color coordinate them. Okay, so I'll graph the first one with you, and then you can pause the video and graph the last three. So we'll graph f at x equals 2 to the power of x. Okay, so our first point is -2 1/4. I'm not going to label this graph. We'll just assume that every box is 1. -1 1/2, 0 and 1, 1 and 2, and 2 and 4. Okay, and just to help with some accuracy, right, if we had a point with an x value of 4, it'd be 4 and 16. Okay, so now we're just going to connect all those dots. Okay, and we'll extend the graph on both ends. So that's the graph of f at x equals 2 to the power of x. Go ahead, pause the video, and graph the other three on the same grid. Okay, so there's all four graphs on the one grid. Some things I want you to notice. Obviously, the base in this function was 2. The base in this function was 3. The base in this function was 4, okay? And if we look at those three on the graph and compare them, as the base got bigger, so from 2 to 3 to 4, the graph got more steep, right? Because this was the graph of 2x, this was the graph of 3x, and this was the graph of 4 to the power of x. And the blue line was the most steep. So maybe we can conclude that the higher the base value, the more steep the graph is going to be. Also notice they all had the same y-intercept. Their y-intercepts were all 0 and 1. Okay, their x-intercepts were a little different, right? Okay, in my graphs, they were very hard to draw in here, but looking at your graphs at home, I'm sure it's a little bit more obvious to you that none of these graphs touch the x-axis, right? As the x values get smaller and smaller, all the graphs get closer and closer to 0, right? But they never actually touch that x-axis, because the x-axis here is a horizontal asymptote. So we say that there is no x-intercept for these exponential graphs. It does not exist. Okay, and the last thing we're going to do is we're going to write a conclusion about the b values. Okay, so the general form of an exponential function is f at x equals b to the power of x, and b is just the base. Okay, so here the base was 2, here the base was 3, here the base was 4, here the base was 1. So we notice that as the b value increases, the graph gets steeper. Likewise, as you read the graph from left to right, the bigger the base of the function, the quicker the y value gets larger. right? If we look at that blue graph, right, as we read the graph from left to right, the y values get quite steep very quickly compared to the gray graph. They still get pretty steep quickly, but not as quick as the blue graph. Okay, so those are two conclusions you can make from this side of the page. I would like you to now pause the video and fill in these three tables. So now we're going to look at what happens to an exponential graph when the base is a fraction. Okay, so do the same thing, fill out all the y values. So I'll do the first one with you. So when we plug in -2 for x, it's going to be 1/2 to the power of -2. So remember that -2 gets distributed to the numerator and the denominator. Okay, and 1 to the power of anything is just 1. Okay, and now, since we have a negative exponent, let's eliminate that negative exponent by taking the reciprocal of this function. So the reciprocal of 1/2 to the power of -2 is just flip the numerator and the denominator and make the exponent positive. So it's going to be now 2 in the numerator to the power of 2. So our answer here is 4. Okay, so pause the video and try that for the rest of the three tables. Okay, so this is what you should have got once you filled in all of the y columns in the tables. Now let's go ahead and graph each of these functions. So I'll do the first one with you. Okay, so -2 and 4, -1 and 2, 0 and 1, 1.5, 2 1/4. I can also add a point, -4 and 16. Helps with the accuracy of the graph. Okay, now we'll connect the dots. Okay, go ahead and graph the other two. So pause the video and graph them. Okay, so there's all of your graphs. I want you to notice that the y-intercept for every single one was still the same. It's all 0 and 1. And of course, the x-intercepts here do not exist because each of the three graphs get very close to the x-axis, but they never touch or cross the x-axis. Okay, and you can notice the same properties as before. As you read the graph from left to right, as your x values increase, your y values decrease. So it's basically just the flipped version of the graphs on the other side, right? As the x values increased on the other side, the y values also increased. Here, as the x values increase, the y values decrease. Okay, so let's make some conclusions. So the domain of all these exponential functions is going to be x as an element of the real numbers, right? Because these graphs keep extending to infinity and they're going to incorporate all x values. There's no restrictions on the domain. The range, however, there are some restrictions. Okay, the two sets of graphs that we did today, the range can only encompass y values that are greater than 0. Right? Because these graphs did not cross the x-axis or touch the x-axis. Okay, when we look at the graphs from the first page, all the b values were greater than 1. Okay, so those were the graphs where all the b values were greater than 1. And this represents what we call exponential growth, because as you read the graph from left to right, the y values increase, hence the growth. Okay, these guys here represent exponential decay, because as you read the graph from left to right, the y values decrease. And then obviously, f at x is equal to 1 to the power of x is a linear or horizontal line, right? Because 1 to the power of anything is just 1. Okay, the other thing that we learned is the function f at x equals b at x is our base graph for any exponential function, okay? It has a horizontal asymptote, so a horizontal line on the graph where the exponential functions do not touch or cross. And in these cases, it was the x-axis. So we'd say the horizontal asymptote has an equation of y equals 0, right? Because y equals 0 is that x-axis, and none of these graphs ever touch or cross the y-axis. Okay, the last thing that we noticed is the larger the b value when we're dealing with exponential growth, so when b is not a fraction, okay, the larger the b value, the faster the y values increase. Okay, we realized that on the first page. We wrote that sentence at the end of the first page. The smaller the b value, when we're dealing with b values that are fractions, the faster the y values decrease. Okay, so see if you can make sense of those simple properties of exponential functions, and then go ahead and try graphing and stating the domain and range of the following functions. You will graph using a table of values, just like we did in the lesson.